This video is on solving literal equations. It's lesson 29 in your book on pages 171 through 176. So what in the world is a literal equation? A literal equation is an equation with more than one variable, meaning that it will not only have x but also y, or it'll have a and b, or x and a. The solution for the specific variable will be in terms of the other variables and numbers. So if you're solving a literal equation for x, you're going to get x equals still, but instead of having x equals some number, you're actually going to have x equals an expression with variables in it. For example, here we have a literal equation, and this needs to be in your notebook. 2x plus 3y equals 10, and we want to solve this equation for y. Now the goal of this is still the same. We want to get y by itself. We want to have y equals something, and it's something that we could plug into this equation to get a true statement. So we want to get y by itself. Now here's our y. We want to get it by itself, so it is going to stay where it is. Now, we're going to do opposite operations in opposite order. So first, let's think about if we knew what x and y were, or if we knew what y was, right? The first thing we would do would be to multiply y by 3. So our first step would be times 3. And then after that, we would add the 2x. So our second step would be adding 2x. Now, in order to solve this equation for y, we are going to do opposite operations in opposite order. So instead of adding 2x last, we are going to subtract 2x first. That takes care of our last operation. Now what I do to one side, I must do to another. 2x minus 2x gets me 0 on the left side, so I'm left with 0 plus 3y. Now on the right side, 10 and negative 2x are not like terms. They don't have the same variables to the same powers, so I cannot combine them. So instead of combining these two, I'm just going to write them as is. 10 minus 2x. Now remember I said my first step would, if I knew what y was, would be to multiply it by 3. So I'm going to do the opposite of that and divide by 3. That takes care of that. Now what I do to the left side of the equation, I have to do to the right side, so again, I'm going to divide by 3. Now I can just leave the equation in this form. Y equals 10 minus 2x all over 3. That's one possible solution. If I were to plug this into my original equation for y, I would get a true statement. However, I can simplify it just a little bit further. See how I've got this whole expression divided by 3? That means that I have 10 divided by 3 minus 2x divided by 3. So I can also say that y equals 10 divided by 3 minus, because that's my sign right here, 2x divided by 3. And then if I had any fractions that I could reduce, I would reduce those at this point. This is another solution for y. Here's another example of a literal equation, and this needs to be in your notebook as well. So here I have an equation, and I want to solve this for p. So p is the variable that I am trying to get by itself. Now notice here that I have 4p on one side and 1p on the other side of the equal sign. Before I can get p by itself, they both have to be on the same side of the equal sign. So I'm going to use opposite operations to get both p's on the opposites are on the same side of the equal sign. So I'm going to subtract p, because see this is plus p, so if I subtract p, I'll get 0. And if I do that to the right side of the equation, I have to do it to the left side also. So I have 4p minus p, which is 3p, plus 2a, minus 5 equals 6a. Alright, so here's p. I'm trying to get p all by itself. So p is going to stay where it is. It's not going to move. Now, if I knew what p was, the first step I would take would be to multiply it by 3 times 3. After I multiplied 3 times p, my order of operations says I would need to add 2a. Since I add left to right. And then after I added 2a, then I would subtract 5. Okay, so in order to solve for p, I'm going to do opposite operations in opposite order. So I'm going to start with the last thing I would be doing, which would be subtracting 5. And I'm going to do the opposite. So I will add 5 to both sides. Now when I do that, I still have 3p plus 2a. Negative 5 plus 5 is 0. And then 6a and 5 are not like terms because this one has an a and this one does not. So I can't combine them. So I will just write them as is, 6a plus 5. Now remember I said the next thing I would do would be to add 2a. So I'm going to do the opposite and I'm going to subtract 2a. Now I'm still left with 3p on the right side, or I'm sorry, the left side. 2a minus 2a is 0. Now 6a and 2a are like terms because they have the same variable, a, to the same power, 1. So I can combine these. So 6a minus 2a, 6 minus 2 is 4, and we still have a plus 5. And then the first thing I said I would do would be to multiply by 3. So the last thing I'm going to do is divide by 3. That would cancel out on this side. And over here, divided by 3. That takes care of that. And so I have p equals 4a plus 5 all over 3. Now, that's one solution. It's also possible to write the same equation, but instead of having everything over 3, I could divide each term by 3. So I could also say p equals 4a over 3, or 4/3 a, 4 divided by 3 times a, plus 5/3. And then if I had anything that needed to be simplified there, I would reduce, but I don't. So either of these are acceptable answers for p. Alright, here we have another example that needs to be in your notebook. It says the formula C equals 5/9 F minus 32 expresses Celsius temperature in terms of Fahrenheit temperature. Find the Fahrenheit temperature when the Celsius temperature is 20. Alright, so now what they're telling us to do is use the Celsius to find the Fahrenheit, right? Find the Fahrenheit when the Celsius is 20. Now, this equation gives us a way to find Celsius when we are given Fahrenheit. But we need to actually do the opposite. So what I'm going to do here is I'm going to solve this equation for f. Now, if I knew what f was, the first thing I would do would be to subtract 32. And then, after I subtracted 32 from f, I would divide by 5/9, or I would multiply by 5/9, which means, there we go. Sorry about that. And then I would have my Celsius temperature. So in order to get f by itself, the Fahrenheit temperature by itself, I'm going to do opposite operations in opposite order. Alright, so instead of multiplying by 5/9 last, the first thing I'm going to do is divide by 5/9. Or I can say I'm going to multiply by 9/5, because dividing by a fraction is the same thing as multiplying by the reciprocal. What I do to one side of the equation, I have to do to the other. Now, 5 times 9 is 45, 9 times 5 is 45, and those cancel each other out. So I have 9/5 times c equals f minus 32. I've undone the times 5/9, so then remember I said the first thing I would do would be to subtract 32, so I'm going to do the opposite and add 32 to both sides. Okay, so these cancel, and on one side I'm just left with f equals. Now here, 9/5 times c and 32 are not like terms. I cannot combine them, so I can just write them as 9/5 c plus 32. Now this is an equation that I can use if I have Celsius to find Fahrenheit. So we want to find the Fahrenheit temperature when the Celsius temperature is 20 degrees. So that means C equals 20. So I'm going to plug 20 in right here for C to find the Fahrenheit temperature. So I have 9/5 times C, which is 20, plus 32 equals my Fahrenheit temperature. Now 9/5 times 20, 9 times 20 is 180, and 180 divided by 5 is going to give me 36, and then I've got plus 32. 36 plus 32 is 68. So my Fahrenheit temperature when Celsius is 20 is 68 degrees Fahrenheit. Alright, here we have another example that needs to be in your notebook. It says the formula for the circumference of a circle is C equals 2 pi r. Now we know C is circumference, r is radius of the circle. If the circle circumference is 24 inches, what is the radius? Leave the symbol pi in the answer. Now that means that instead of plugging in 3.14 for pi, we are going to leave it alone. So we know the circumference is 24 inches and we need to find the radius. Our equation gives us how to find the circumference if we know the radius, and we need to do the opposite. Now if I knew the radius and I was going to solve this equation, I would plug in the number for r, and then the first thing I would do would be to multiply it by 2 pi, 2 times 3.14. So in order to solve for r in this equation, I'm going to do the opposite of that and divide by 2 pi. So that means that C, circumference, divided by 2 pi equals the radius. Now this says, what is the radius, r, if the circumference is 24 inches? So that means C is 24, and we can sub a number into this equation. So we have 24 divided by 2 pi equals the radius. Now remember, we don't want to plug 3.14 in here because it says leave the symbol pi in the answer, but we can take 24 divided by 2. 24 divided by 2 is 12, and we still have pi in our denominator. So the radius of this circle is 12 over pi. Now here's our last example. It needs to be in your notebook. The Ramirez family is taking a trip to the coast. They live 270 miles from the coast. They want to make the trip in 4.5 hours. Use the distance formula, d equals rt, to determine the average speed the family needs to drive. Alright, so what we need is to find the speed, or rate. So we want to solve this equation for rate. Now if we knew the rate, we would multiply rate times time. Since we don't know the rate, we are going to do the opposite and divide by time. So now over here time cancels, and we've got d divided by t, or distance divided by time, equals r. They've given us a distance, 270 miles. That's how far away they live from the coast. So d is going to be 270 miles. They've also given us a time that they want to make the trip, which is 4.5 hours. So their time is 4.5 or 4.5 hours. In order to find r, their rate or speed, we're going to plug these numbers into this equation. So we have 270 miles, and they're going to travel those 270 miles in 4.5 hours. When we do that, 270 divided by 4.5, we get 60. Now, what is our units? It's miles divided by hours, or miles per hour. So in order for the Ramirez family to make it to the coast in 4.5 hours from their house, they need to travel at an average speed of 60 miles per hour.